MatDeck Notes is an interactive document-based engine which allows you to combine your Python code with countless GUI toolboxes as well as MatDeck script and even your own GUIs. This comes combined with narrative text editing, which will allow you to present your code and its solutions easily to other people. It allows you to not only showcase what the code can do, but also explain it all in one document and making it easy to pass to other people, as you can export the document as a PDF or even as HTML. Here we can see an example of what a MatDeck document might look like. First, we start off by importing the data with MatDeck's Excel toolbox, which allows us to directly import it without any code and save it in the variables data1 and data2. Once we have imported our data with the toolbox, we then use two MatDeck functions to combine the data into a matrix, and then we use the regression table function to run typical regressions on this dataset to see if any of them are any good fits. We can see that none of the typical regressions are a good fit for our data, as this R-square value is incredibly low, meaning it's not accurate. However, what we can now do is import our Python code, which will allow us to use more customized and accurate AI learning to predict values to a much higher accuracy. We can do this with the call function, which allows us to use any Python function directly in the MatDeck document as a native function. As you can see, decision tree model and random forest model both look like native MD functions, but they are actually Python functions which we have been able to import from our previous work. They can be found here in our functions document, which is a Python file. When you first use the call function, it will actually return a completely empty function which is waiting for a function name as well as any arguments. And then when you add the function's name and arguments of the Python function, it will be treated just like any other native MatDeck function. Here, when we use the call function, we store the returned value of the decision tree model function into a variable called data prediction1, and we do the same thing with the random forest model function and data prediction2. Now, when these functions return their values, we can actually just write data prediction1 is equal to, or data prediction2 is equal to, and see their values directly in the document. There's no need to have another window which prints or shows our output. We can have it all in one space. As well as having all our outputs and inputs all on one document, you can see how throughout this document we've included the narrative text editing to better explain our code and make it easily readable and understandable to other people. Combined with all this, we can also directly embed 2D and 3D graphs in the document. As you can see, we have one 2D graph here on which the training data is plotted. The training data has over 25,000 points, and it is all on this one graph. And beneath it, we see how the predicted data compares to the training data. As you can see, once again, the data is in green, and prediction 1 and prediction 2 are shown by the purple cross and the red cross here. Once again, you can see how we have our graphs on the same document as our code and also its explanation. And not only this, but these graphs are holding quite a large amount of information in themselves. And still, once again, we can have all of our features in one place. But the call function isn't the only way to write Python code in a MatDeck document. We can also write the Python code straight into the document. As you can see here, we have model 1, which is an AI model defined by the following code. And then beneath it, we have model 2, which is a slightly more complex AI model, which is defined by this code. And at the bottom, we have our MatDeck functions and any MatDeck code we need. Now, another unique feature which we can see right now in the MatDeck document is how we can add GUI and GUI widgets straight into the canvases. As you can see here, we have two buttons, Model 1 prediction and Model 2 prediction. These buttons are defined by Model 1 test and Model 2 test. Now, on the Model 1 prediction event function, we use the AI Model 1 trained above and the Model 1 parameters to predict whether or not the person will churn. And for the Model 2 prediction, we will predict the same thing, but with AI Model 2 and Model 2 parameters. It will just return a true or false statement, which will tell us whether the person is likely to do it or not. And now we can test this out by clicking Model 1 prediction. As we can see, it returns no. And if we click Model 2 prediction, it actually returns yes. Since MatDeck is a live document, we can change Model 1 parameters and make it so that we can run the code again without actually needing to evaluate the whole document. This is done by first changing the parameters, and then once we do that, all we need to do is click Model 1 prediction to see if the results vary. As we can see, the results do vary, and the Model 1 prediction is now yes with these new parameters. This is all done through the collapsed canvas here. If we want to open it, we simply need to click on it. And here we can see all the code that we have. Now to collapse the canvas or code block again, we just need to right hand side click and select collapse code. As you can see, the MatDeck document allows you to organize your thoughts and turn them into reality, as you can use Python code, MatDeck script, and a plethora of GUIs, as well as your own custom widgets or GUIs in one document, meaning that you can have your explanation and solutions on one page without needing to change from the output and input layer of your code.